What's an analytic manifold? Well, if you know your differential geometry, fine. If this notion is new for you, then think of an analytic manifold as something that locally looks like a piece of Rn. So what do we mean by that? If, I don't know, this is our manifold M, then we cover this manifold with open sets. Let's say this is an open set, let's call it uj, and these open sets come with maps phi j, which map this uj to some part of Rn. So here is an Rn, and maybe this is where uj is mapped by this phi j. And let's say there are many such open sets. Let's say this is uk, and uk is mapped by phi k also to some part of some Rn. So let's say this is phi k of uk. And now what we do is we cover the whole manifold with such u's. So there is a set of u's, and the union of all these u's is the whole manifold. And when we say the manifold is analytic, then we mean that if we look at the intersection of two such u's here, so there's a part in this Rn here where this intersection is mapped to, and there's a part in this Rn where this intersection is mapped to. And now we can find a map that takes us from here, let's say from here to here, by just first taking the inverse of phi k. So we go from this Rn to the manifold, and then with phi j we go on to this Rn. So we have a map from Rn to Rn, and this is the map that we want to be analytic. And analytic for us means it can be the function, this function here can be expanded into a convergent power series.